Hello everyone. Today let's solve the Leetcode problem number 207, course schedule. So what the question says, there are total number of num courses that you have to take. So courses you have to take, nothing but the number of courses. So labeled from 0. There is labeled from 0 to num courses minus 1. So number of courses minus 1. You are given an array prerequisites where prerequisites of I is nothing but A of I, B of I. Indicates that you must take course B of I before you want to take the course A of I. So before taking the course B of I, we have to take the course A of I at any cost. They have mentioned clearly over here, right? So this one. First you have to take the course A of I. For example, for the pair 0, 1 indicates that to take course 0. So here, as per the above statement, we have to take the we have to take the course 1 before we take the course 0, right? So that's the example. That's what they have said here. So we will return true if you can finish all the courses. Otherwise, we will be returning false. So this is fine. Next, let's consider this example. Input they have given number of courses equals 2 and prerequisites equals 1, 0, right? So when they are saying number of courses equals 2, that means that we are having two courses, nothing but one is labeled as 0 and one is labeled as 1. Nothing but we have two courses, one is labeled as 0 and one is labeled as 1. So prerequisites they have clearly mentioned here, that is 1, 0. So and also as per this statement, so we have to complete the course 0 before taking the course 1. Strictly they have mentioned this statement as well, right? So this is one thing. Next step what we are doing, we will be building the adjacency list. So we start by constructing the adjacent list using the prerequisites, this one. Then we will make use of the map. First thing, the map will store the courses as keys. So we will be storing the courses as keys and their prerequisites as values. So again, I'm telling we'll be making use of map. First, the map will be storing the courses as keys and their prerequisites as values. First thing, for the given prerequisites 1, 0, here in this example, we add course 1 with its prerequisite 0 to the map. So how does the map look like? So here, suppose this is map. So just give me a second. This is map. Then now, so this one is, so just give me a second. Yeah. Now, this will be within the array, right? 0. So what we are having for the given prerequisites 1, 0, this one will be, we will add the course 1 with its prerequisite 0. Nothing but the prerequisite is 0. This one is course. We are adding this one in the map. So the map is looking like this initially, right? So next in the step 3, what we are doing, we will perform the DFS, depth first search, on each course that has the prerequisites to check for the cycles. Just for checking for the cycles, we are performing the DFS. So what we'll do first, we will start the we'll start with the course 1 since it has the prerequisite in the map. So this one is already having the prerequisite in the map, nothing but 0. So we will start with the course 1. First, what we will do, we will start the DFS on course 1. Suppose we have 1 and 0. Let's consider this one, 1 and 0. We will DFS DFS on the course 1 basically, first one. We are performing the DFS on course 1. We will mark the course 1 as visited initially. This one will be marked visited by adding it to the set. We will be making use of set along with the map. Map we are already making use of. We will be making use of set first thing. And we will, as soon as we perform the DFS on this one, we will mark the one as visited, right? By adding it to the set. And we will check whether its prerequisite is, we will check whether its prerequisite is present, nothing but 0. Then we have performed the DFS on 1. Next step, we will perform the DFS on 0, right? since course 0 has no prerequisites, we can clearly see that course 0 itself is a prerequisite and course 0 is not having any prerequisite, right? So it can be completed and we can return true for this one. Since 0 has no prerequisites, that is 0 here. If you consider this one in the map, 0 is not having any prerequisite in the map. So it can be completed, and so we will return true for the course 0. This is fair. Next, we will be back to the course 1. This both are completed now. We will be back to the course 1 from the set. How, back to the course 1. Now the 1 is having the prerequisite, nothing but the course 0. We have successfully processed that one. We will remove the course 1 from the set. We will remove the course 1 from the set. Suppose we are having 1 and 0. We will remove the course 1 from the set, right? Then by backtracking, then we will mark the course 1 as fully processed by setting map1 equals null. So this one, we process this one and we got the output true as well. So boolean value for true as well. Now after processing this one, sorry, it has to be only 1. Now we will remove this one from the set, and finally we will set map equals, I'll just set the null to n. So map of 1 will be null now. Nothing but we don't have any prerequisite for the 1 after we process this one, right, for the next step. So here we can also observe that there were no cycles detected, right, during the DFS. So there were no cycles detected during the DFS. So we can conclude that it's possible to finish all the courses. So what's the final result? We can say no cycles were found. So the function will be returning true, meaning that it is possible to complete all the courses. That's what we have got here, right? Output. What are all the things that we have to remember? One thing is course 1 depends on course 0. They have clearly mentioned here. First we have to complete course 0 and then we have to go for the course 1. So course 1 depends on course 0. Second one, DFS shows that we can complete course 0 and then course 1 with no cycles. That we saw in the example, right? This one. And by taking this example correctly, right? By taking this one, map correctly. And therefore, the output will be finally true, indicating that all courses can be finished correctly, right? So let me delete this one and let me come here. Let's implement the same in code, right? Initially, what I'll do, I'll just create a set to keep track of the courses that is being visited. So in the current path, to detect the cycles, I'll just give let set equals new set one thing. Next, let's create a map to represent the adjacency list of graph, where key is the course. We saw in the example that key is the course and value is an array of prerequisites. We had only 0, right? If you remember the example for that course. So let me give let map equals new map. This is fine. Next, let's populate the adjacency list based on the prerequisites. I'll just make use of the for loop for this. For let array of, let me copy this one, prerequisites instead of typing. See, or I should have copied from here itself. Sorry, that's fine. Anyway, prerequisites. Next, if the course is not yet in the map, and if the course is not yet in the map, then we will add it with its prerequisite as the first this one entry in the array. We saw it right in the example. So I'll just make use of the if condition. If not of map dot has array of 0, then map dot set of array of 0 will be having array of 1. This is fair. Next, what we'll do, we could have directly took this one, right? This is fine. Else, what we'll do, if the course is already in the map, then we will append or add the prerequisite to its array. So we can just make use of map.get, right? Map.get array of 0. We'll make use of the push operation. So push of array of 1. This is fair. This is fine. Next, just give me a second. Next, what we'll do, we will iterate over each course in the map. So we'll iterate over each course in the map, that is courses that have prerequisites strictly. So I'll just make use of for loop again for let course dot keys. We are strictly iterating over the each course in the map that have prerequisites. Next, we will perform the DFS to check if there is a cycle in the path. Here we saw we performed this one DFS on 1 as well as the 0, right? I'll just make use of the if condition. If, just give me a second, did I miss anything? Just give me a second. So for this, I should have written this one DFS function first, but that's fine. DFS of course, then we will return false. So this is fine. If no cycles are detected, then we will return true. Nothing but meaning all courses can be finished. So in our example, no, this one was detected, right? I just here, let me return true first. In our example, yeah, no cycles were detected. So we got the output true in the first example. So let's make use of the helper function to perform the DFS on the graph. So let's see. Just give me a second here. So yeah, that's fine. Let's make use of the helper function, right, to perform the DFS on the graph. I'll just give function DFS of parameter course. So here, first what we'll do, if the course is in the current path, a cycle is detected. So we will be returning false. Simple. For that one, I'll just make use of set dot as course. Then we will return false. Next thing, if the course has no prerequisites or all the prerequisites have been already processed, then we will return true. So these are simple. If map.get, so CO course, we just return. This is simple, right? Next, what we will do, we will mark the course as visited in the current path. How we will do that? We will just make use of the set and we will add the course. But it's not already present, right? We are just marking the course as visited in the current path. Next, we will recursively visit all the prerequisites of the current course. So how can we do that? For that one, I'll just make use of the for loop CO get the course. This one is fair. Next, if of DFS, nothing here. Here in this line, what we are doing means, so if any prerequisite has a cycle, then we will what we'll do, then we'll return false. So here DFS of C, right, in a for loop for the, that's fine. I'll just return false. This is fair. Next, let's unmark the course after processing. Nothing but we are backtracking, right? So we'll make use of the delete. So after in the example we had seen the same thing, right? After we had assigned 1 to the prerequisite 0, after the operation, what we had done, we will check for the 0, right? Next. So that's what we are doing here. We'll mark the course as completely this one. We'll unmark the course after processing. Nothing but we are backtracking. For that one, I'll just make use of the delete, set.delete of course. Then we will mark the course as fully processed by setting its prerequisites to none. We had seen, right, at last, after processing, after all the process got completed, then we will mark that process to null. Nothing but map of 1. We had mark that one to the null, right? So let me give map dot set course null. So this is fine. Then finally what we will do, if no cycles were detected in the path, then in our example there were no, cycles were not detected, right? So if no cycles were detected in the path, then we will finally return true. This is simple. Let me return true. That's it. True. Let me format the code once. Let me hit the submit. Hope everything. What happened here? Unexpected token elsewhere. Line number 7. So what happened here? If I am making use of, it's just fine, right? So what did I miss here? Just give me a second. I think I have missed one more braces here. Let me... Else, what is wrong here? Let me remove these braces. So let the format the document once. This should be correct now. Let's see. Line number 3, map. Oh, this M has to be capital M, right? It's fine. So we are getting wrong answer. 1, 0 and 0, 1. We are getting true. Expected is false. The second example, right? What we have done mistake. Here in the line number 7, the braces, this one, this has to be here, right? So we format the document once again. Let me hit the submit. So again getting wrong. What I have done here is, let me remove this one. One more brace and one more braces here. And here let me add this one, right? We close this one as well. So let me format the code and let me hit the submit. So yeah, now this works correct, right? So I had missed so many braces and I have unnecessarily used the flower brace as well. Here I have just removed the flower braces. That was wrong basically, and I have just added the array, this one, array of 1, right? So now this is working correctly. So what will be the time complexity and the space complexity? So this works absolutely correct, right? So time complexity would be big of v plus e. Why the time complexity is big of e? First of all, where v is the number of courses, right? So v will be, v or the vertex will be the number of courses or nodes, and e is the number of dependencies, nothing but the edges. So we are performing a DFS on the graph, right? To be frank. So that's the reason the overall complexity would be big of v plus e. Let me give, I come here, it would be big of v plus. What would be the space complexity? The space complexity would be big of v plus e as well. Why? For storing the adjacency list, and we are making use of the recursion stack as well. If you can see here, DFS, we are making use of the recursion stack as well, right? So so yeah, here as well. So for storing the adjacency list and the recursion stack in the worst case, this overall space complexity would be big of v plus e as well. So let me come here and give v plus e. So yeah, let me comment this one and let me run the code again. So yeah, everything works correctly, right? So this is it. Thanks for watching, guys.